And finally, we're going to tackle least common multiples of variable expressions, algebraic expressions. So numerically, nothing is different. We're still going to do our ladder for 40 and 16. So let's see, these will both divide by 2 to give me 20 and 8. Those will both divide by 2 to give me 10 and 4. Those will both divide by 2 to give me 5 and 2, and that's the best I can do. Since I'm back to LCM, I'm going to grab everyone from around the outer edge. So that's 2 times 2 times 2 times 5 times 2. That's 8 times 10, which is 80. Now, here's where LCM is majorly different. We already knew that in the ladder, we had to take everybody. In terms of variables, we have to take everybody. What that means is if you see a letter, it's going to be part of your LCM. And if letters have different exponents, with GCF, we took the smallest exponent. With LCM, we're going to take the biggest exponent. So I see an A, my LCM needs A. These both have b to the second power, my LCM needs b to the second power. 80, A, b to the second power. In number 40, again, do yourself a favor. Anytime you see the same number in both terms, numerically, you're guaranteed to have that number. Now, let's look at letters. We have x's here, which is the biggest, x to the third power. Least common multiple just says take the biggest of anything you can find. We have y's here, so we grab it and bring it. Least common multiple, when we're talking about variables, says if you have it, you bring it. And if there are multiple types of it, you bring the biggest of those types. So here, these both have x's. We bring the bigger one, x to the third power. There is a y to the second. It must come along. In number 41, numerically, we have 18 and 27. These will both divide by 3 to give us, not 9, 6 and 9, which will both divide by 3 to give us 2 and 3. So numerically, we have 3 times 3 times 2 times 3. That's 9 times 6. That is 54. So that's not new. It's this algebra part that's new. Do they both have m's? Doesn't matter. There are m's here. Which is bigger? M to the second power. There's an n here. They're both just a plain n, so just a plain n is what we need. I invite you to pause and attempt 42 to 44. I'll meet you back at 45 if you're doing that. Here we go on the middle three. Numerically, 36 and 28. I can cut both of those in half to get 18 and 14. I can cut both of those in half to get 9 and 7. And that's as far as that's going. 2 times 2 times 9 times 7. That's going to be 4 times 63. And that's going to be 232. We have x and x squared, so I'm going to take x squared. It's bigger. Both have y squared, so I don't have to pick. It is just y squared. For number 43, we have 15 and 25. Both will divide by 5, and that's all I can do. So my GCF is 5 times 3 times 5. That's 15 times 5, which is 75. Let's see, we've got x's. They both have x squared, so our LCM has x squared. We got y's. The biggest is just the plain y, 75x squared y. In 44, they both have the common 12, so I just need 12. For x's, the bigger is x squared, and we do have a y, 12x squared y. Groups of 3 follow the same rules. So numerically, we have to say, okay, 29, 20, and 22. Does anything go into all 3 of these? And no, 29 is prime. So forget it. We can't do anything with all 3. But 20 and 22, we can divide both of those by 2 to get 10 and 11 respectively. Which means our GCF here, or sorry, not GCF, we're doing LCM today. Our LCM is going to make us multiply 2, 29, 10, and 11. Oof! 2 times 29 times 10 times 11. So that's 58 times 110. And yet, nope, I do not know that. If we were in class, I would definitely go on to the side and do that. But we're not, and I'm trying not to make these videos too long. So I am going to use a calculator. I know, forgive me. 58 times 110 is 6,380. As far as the variables go, I see an x. It has no exponents anywhere, so I can't put an exponent on it. I don't see any other letters. 6,380x is my LCM. Hopefully that is the biggest number we run into. No promises, though. Next group, the numbers 38, 16, and 26. We're going to say, okay, those can all cut in half. That gets me 19, that gets me an 8, that gets me 13. Oh, not good numbers. But nothing else to do here. 19 and 8 and 13 certainly have nothing in common. Neither do any of their pairs. So we are just going to have 2 times 19 times 8 times 13. Now 2 times 19 is 38. That's not bad. 8 times 13 is a little less pleasant. It's 104. And again, in class, do it on the board. Here, in the interest of time, I am using a calculator. 38 times 104 is 3,952. Let's look at letters. I have an x. There are no exponents on x, so I just have the x. We have y's. There's a y that has an exponent. So its exponent comes to our LCM. 3,952, x, y to the second power. I invite you to pause and give 47 and 48 a shot. Let's see, these will all divide not by 2, but by 3. That gets me 12 and 9 and 6. Those will all divide by 3, giving me 4 and 3 and 2. 2 of those will divide by 2, so I need to do that. Bringing along the 3 that I didn't touch. All right, so numerically, we have 3 times 3 times 2 times 2 times 3 times 1. That doesn't feel too bad, other than the fact that I have no space to do it thanks to being trapped by my iPad. So let's see. 3 times 3 times 2 is 9 times 2. 9 times 2 is 18. 2 times 3 times 1 is 6. 18 times 6 is 108. Really squeezing things in here. Let's see. X's. Definitely. Biggest exponent is a 3. We also have a y here, so it comes along. 108, x to the third y. Finally, we have number 48, where we have 14, 35, and 21 as our number components. Luckily, that's not too crazy. They'll all divide by 7, and 2, 5, and 3. No matter how you group those, there's nothing we can do. So we do just need to do 7 times 2 times 5 times 3. Whoop. Did not want my highlighter there. That gives us 14 times 15, and that is 210. And again, you can check me on that if you like. I just happen to know 15 times 15 is 225, so 15 times 14 is 15 less than 225. Variables, we've got x. Biggest exponent on x is a 2. That's all we have. So our final least common multiple is 210, x to the second power.